Hey everyone, and welcome to The Explainer. Today, we're taking a journey through one of the absolute most fascinating systems on our entire planet. I want you to think of the weather outside your window right now as this grand, incredibly dynamic recipe. The ingredients? Well, they're actually surprisingly simple. It's really just water, heat, and air. But the way these basic ingredients mix and move and react, that creates everything from a gentle, refreshing breeze on a spring day to a catastrophic, world-altering storm. Okay, let's dive right into this. Think about this for a second. What could possibly connect a microscopic floating speck of dust to a roaring 500-kilometer-per-hour storm? I mean, it sounds totally impossible, right? But the answer actually lies in the sheer scale of the energy we're dealing with and the incredibly delicate chain reactions constantly happening within our atmosphere. To truly wrap our heads around that atmospheric energy, just think about this number: 30,000 degrees Celsius. That is the temperature of a single lightning bolt. To put that into perspective, that is literally 5 times hotter than the surface of the sun. No joke. When electrical charges separate inside storm clouds, they eventually have to discharge. And that discharge heats the surrounding air so explosively fast that the air just rapidly expands, creating this immense shockwave. And that shockwave, that's what we hear as thunder. So yeah, that is the intense level of energy we're talking about here. Now let's talk about the foundational moving ingredient of this whole system: wind. Wind is, at its core, just moving air. It happens simply because the sun doesn't heat the earth perfectly evenly. Warm air naturally rises, and cooler air rushes in to take its place. This seemingly basic temperature difference across our planet's surface can actually generate astonishing power. We're talking about the fastest wind gusts on Earth being recorded at over 400 kilometers per hour. So what happens when you add water to that moving air? We get the water cycle. Every single day, trillions of tons of water evaporate from the Earth's surface. Trillions. And as this water vapor rises and cools down, it condenses. Now, remember that microscopic speck of dust we mentioned a minute ago? That is exactly where it comes into play. Water vapor actually needs something physical to cling onto, what we call condensation nuclei, like dust, salt, or smoke, to form a droplet. Those tiny droplets collide, they grow, and eventually they get heavy enough to fall back down to the ground as precipitation. So here's the crazy part. When all those microscopic droplets gather together up there, they carry immense, almost unbelievable weight. A single thunderstorm cloud floating right above your head right now can weigh millions of kilograms. We're talking hundreds of thousands of tons. It seems physically impossible for something that heavy to just stay up in the sky, doesn't it? But it floats because all that immense weight is distributed among incredibly tiny droplets spread out over just an astonishingly massive volume of air. And depending on exactly how these tiny droplets gather, we get a few different main types of clouds. You've got your high, really thin cirrus clouds that usually mean fair weather is coming. Then there are the classic puffy cumulus clouds you see on a bright sunny day. And we can't forget the flat stratus layers that stretch way out and just give us that gloomy drizzle. But then we have the cumulonimbus. These are the absolute giants of the sky. They can tower over 18 kilometers high. These are the violent engines that brew deadly lightning, torrential rain, and even hailstones larger than grapefruits. And you know, when the atmospheric oven gets a little too hot inside those cumulonimbus clouds, things get incredibly violent. Here is the exact step-by-step recipe for a tornado. First step: warm, moist air violently collides with cold, dry air, which sparks really strong thunderstorms. Next, winds changing speed and direction at different altitudes cause that air to start spinning horizontally. That rotation then gets pulled downward, a distant funnel develops, and finally, boom, it makes its terrifying touchdown on the ground. When that touchdown actually happens, the sheer scale of it is just terrifying to witness. You are looking at a violently rotating column of air, physically connecting a massive dark thunderstorm directly to the fragile ground right below it. It is literally a bridge of destruction made entirely out of fast-moving air and condensed water vapor. And at the absolute most extreme end of the scale, we have what are called EF5 tornadoes. Inside that rotating funnel, wind speeds can easily exceed 500 kilometers per hour. That is enough sheer rotational force to completely obliterate well-built structures, literally sweeping their foundations clean in just a matter of seconds. And interestingly, the vast majority of these immense atmospheric phenomena happen right in the United States, which really represents the peak of concentrated atmospheric violence on land. Okay, let's zoom out from the incredibly concentrated fury of a tornado And look at the sprawling, massive structure of a hurricane. The contrast here is just stark. On one hand, you have this giant, swirling tropical storm system that covers hundreds of kilometers of open ocean. But right dead in the center, the eye of the storm, it is eerily calm and clear. And that's despite the extreme, deadly winds ripping through the eye wall directly surrounding it. This completely calm center can actually be anywhere from 20 to 60 kilometers wide. The scale of these tropical cyclones is truly mind-blowing. They rely completely on warm ocean waters exceeding 26.5 degrees Celsius just to form and maintain their spin. And because they draw up such massive, massive amounts of heat and moisture, get this, a single hurricane can release more energy in just one day than all of humanity uses in several months. Let that sink in for a second. Our absolute most powerful global power grids completely pale in comparison to a spinning vortex of warm ocean water. Thankfully, though, after the storm passes, the leftover atmospheric ingredients sometimes give us a bit of a visual breather. And here's a fact that almost feels like magic. Every single observer actually sees their very own completely unique rainbow. Because the exact angle of light hitting the water droplets depends entirely on precisely where you are standing, the vibrant arch you're looking at up there, it belongs uniquely to you. Nobody else is seeing exactly what you're seeing. But as cool as it is, it's not magic. It's just a really elegant three-step process of physics. When sunlight hits a floating water droplet, it actually bends upon entering, which we call refraction. Then that light bounces off the inside back of the droplet. That's reflection. Finally, as it exits the droplet, dispersion happens. The light separates out into the 7 distinct colors we see painted across the sky: red, orange, yellow, green, blue, indigo, and violet. All right, so up to this point, we've been talking entirely about weather, but we really need to zoom all the way out to the macro level to understand how our planet as a whole works. Weather is what changes daily. It's the thunderstorm outside your window right this second. Climate, on the other hand, describes the long-term patterns of those conditions averaged out over decades. Think of it kind of like this. Weather is your mood on any given day, but climate is your overall personality. As these long-term patterns build up across the globe, we see Earth's incredibly diverse environments emerge. We've got tropical climates that stay hot year-round and see heavy rain, like the Amazon basin. We have temperate zones that boast 4 distinct seasons, covering a lot of North America and Europe. And of course, we have Mediterranean climates, which feature those hot, dry summers that are absolutely perfect for a vacation to Greece or Italy. But actually, let's take a quick look back at that desert category for a second, because I want to drop a really surprising fact on you. Antarctica is technically the world's largest desert. I know we almost always associate deserts with blistering heat and endless sand dunes, like the Sahara. But scientifically speaking, a desert is defined entirely by having very little rainfall or precipitation. So despite being covered in miles of ice, Antarctica receives almost no fresh snow or rain at all, making it a vast, freezing desert. And hey, speaking of global patterns, we absolutely have to talk about seasons. And I want to forcefully debunk a major misconception right now. A lot of people mistakenly believe it gets hot in the summer because the Earth physically gets closer to the sun in its orbit. That is completely incorrect. Seasons are caused purely because the Earth's axis is tilted about 23.5 degrees. It's entirely about the angle that the sunlight hits the different hemispheres throughout the year, not our distance from the sun. This 23.5-degree tilt is exactly what creates our beautiful yearly cycle. Spring brings rising temperatures and new plant growth. Summer hits us with the warmest weather and the longest daylight hours. Autumn cools things right back down as the days shorten up, and winter brings the cold. So the really crucial takeaway here is that because of this tilt, the hemispheres always experience totally opposite seasons. When the northern hemisphere is tilted toward the sun and just baking in the summer heat, the southern hemisphere is tilted away, totally wrapped up in winter. So we've covered a lot today, from the evaporation of a single microscopic droplet to the massive continent-spanning energy of a hurricane, the incredible physics of a rainbow, and the planetary tilt that gives us our seasons. The next time you step outside, feel a gentle breeze on your face, or watch a dark, heavy storm rolling in over the horizon, ask yourself, which of these immense atmospheric forces are at work right now? Keep observing, keep asking questions, and never stop wondering about the incredible dynamics shaping our sky. Thanks so much for joining me on this explainer, and I'll catch you next time.